Hello guys, this is Dr. T and welcome to Clinical Medicine with Dr. T. So guys, in this video, we're going to talk about muscle relaxants, and as most of you have seen that I've been focusing on anesthesia. This is my second week in anesthesia as an intern rotating there, and that's why you see a lot of anesthesia that I upload lately. It's because I'm doing anesthesia now. So in this video I want to talk about muscle relaxants, but before we can talk about the actual drugs and how they work, their side effects and all those things, the classes of muscle relaxants and all of that, we need to talk about the neuromuscular junction, because that's where everything happens, the neuromuscular junction. So muscle relaxants. Muscle relaxants are drugs that relaxes muscles. They sort of like paralyze the muscle. They relax the muscle, and that is done. Indications for muscle relaxants, we are going to talk about them. Why would you want to relax someone's muscles? We are going to talk about those. But let's just talk about now the neuromuscular junction. So remember, so we're talking about the neuromuscular junction. The neuromuscular junction. So we're going to talk about, so in the neuromuscular junction, it's made up of about three things there. So we've got a presynaptic neuron, we've got a presynaptic neuron, we have a presynaptic neuron, and we have a motor end plate. This is a muscle, it's called a motor end plate. Motor end plate. So this is a muscle. It's in the post synapse. So this area here is called synaptic cleft. Synaptic cleft. This is called a presynaptic, postsynaptic, synaptic cleft, presynaptic neuron. Remember, a neuron has got those myelin sheaths, but that's not our focus today. And we're gonna have them like that, myelin sheath. But that's not our focus. So we're saying that a neuromuscular junction has got a presynaptic neuron, then there's a synaptic cleft, and then there's a muscle or motor end plate. Those are the three things that make up a neuromuscular junction. Now, we all know that in order for this muscle to contract, it must receive some action potential from the presynaptic neuron. Remember, this is a space. There's a gap here. There's a gap. So the end bulb of this presynaptic neuron, this part, is not attached to this part of the muscle. There's a space there. They are not in contact. That's what I'm trying to say. So action potentials will be transmitted down here. When they get here, the body found a way of making sure that that action potential can still affect the muscle, even though the muscle is not in direct contact with the end bulb, right? That's fine. Let's go back to this part here. So we consume food that contains a molecule called choline. That molecule, when it enters the neuron, it combines with acetyl-CoA to form acetylcholine. To form acetylcholine, also written this way, to form acetylcholine. And this is made possible by an enzyme called choline acetyl transferase, right? Not very important, but it's nice to know. So when choline enters here, it's combined with acetyl-CoA enzyme to form acetylcholine. And that acetylcholine is the one that is transported to the end bulb and stored in vesicles. So that acetylcholine is now inside there, and it's stored waiting for an action potential to actually happen. So it said that, so as we all know that acetylcholine is a neurotransmitter, and it's not just a neurotransmitter, but it's an excitatory. It's not an inhibitory, it's an excitatory neurotransmitter. So it excites cells. So now the acetylcholine is stored in those vesicles, and it said that in each vesicle there is about 10,000 molecules of acetylcholine. Now here is where the magic happens. So you get an action potential that gets transmitted down the axon. It goes down like that and enters the end bulb. Once it enters this, it causes calcium channels to open. Once an action potential makes it to this part of the neuron, it causes action potentials. It causes calcium channels to open. So the minute an action potential is transmitted down this axon and then it enters here, it causes calcium channels to open. So calcium channels, they open in response to an action potential. Now, what happens when calcium channels open? Calcium enters the end bulb. So there's an influx of calcium. That calcium, let's give it this color. So that calcium comes and attaches on the walls of the vesicles Once that happens, this vesicle now starts to migrate towards the end of the bulb. When it does that, it ends up fusing with this with the wall of the bulb. It fuses there, and when that happens, the acetylcholine molecules, so this process is called exocytosis. So the molecules, the acetylcholine molecules, they end up being deposited into this synaptic cleft by that process of exocytosis. Remember, those neurotransmitters, that they carry electricity because they are neurotransmitters, so they carry electrical energy. So now you have your acetylcholine that is in the synaptic cleft. On the other side, on the motor end plate, you've got other receptors which are called nicotinic acetylcholine receptors. So the black ones here are called your nicotinic receptors, in short, nicotinic receptors. So what happens is that the acetylcholine comes in and attaches to its receptors, the nicotinic receptors in the motor end plate. When that happens, these receptors, they undergo what is called a conformational change. It's like a structural change. When that happens, sodium starts to come in. Sodium starts to come in into the muscle. So there's an influx of sodium into the muscle now. Sodium is positively charged, so it depolarizes the muscle. When the muscle gets depolarized, it contracts. So that's how you get from there to here, to get a muscle contraction. So you get an influx. So the most important thing is that once acetylcholine has been released into the synaptic cleft, it goes and attaches on the receptors, the nicotinic receptors, which are found in the surface of the muscle. When they attach there, those receptors, they undergo a conformational change, and they allow sodium now to come into the muscle, and then the muscle becomes depolarized, becomes more positive inside compared to the outside. And then a muscle contraction happens. We need muscle contraction to do everything. When we are walking, talking, sleeping, or not sleeping. When we are walking, talking, actually even when we are sleeping, because we are still breathing. So there's a certain group of muscles that must contract, and then there's a certain group of muscles that must relax in order for us to walk. That's why if all your muscles are all relaxed, you can't walk. You just become flaccid. You've got flaccid muscles. And the opposite is also true. You cannot walk if all your muscles are contracted. That's why when you walk, a certain group of muscles must contract, a certain group must relax. So this is where we are. So remember, when the action potential came in and was transmitted into the end bulb, it caused calcium channels to open, and then an influx of calcium resulted, and that caused this to depolarize as well, because now the inside was becoming more positive than the outside because of those calcium cations. Remember, cation is positively charged, so it caused the inside to be more positive, and that's called depolarization. So yeah guys, I hope you understand this. It's very crucial and very important. So we are going to talk about pathologies of the neuromuscular junction, so that while we are here we just understand everything and not only muscle relaxants. So what was something I was thinking about I wanted to say now. Okay, now this muscle must contract and it must also relax. We can't have a muscle that is overstimulated and is just continue to contract and contract and contract. But as long as the acetylcholine is there, that muscle is going to keep contracting. So what happens is that the acetylcholine, once it detaches from the receptors, the nicotinic receptors, as it moves out of the cleft, it's met by an enzyme that breaks it down. That enzyme is called acetylcholinesterase. Acetylcholinesterase. So it breaks acetylcholine into choline and acetyl. So this enzyme is very important to make sure that the effects of acetylcholine are not exaggerated, and then the muscle does not continue to contract and contract and contract without relaxing. So that enzyme is very, very important. So guys, let me see if I can make a summary of these steps. The first steps is that we have an action potential that has been generated and has been transmitted down the axon into the end bulb. Once it gets there, it causes calcium channels to open. Number 3, once calcium channels have opened, so there's depolarization of the end bulb, and that causes acetylcholine to move towards the wall of the end bulb, and exocytosis occurs, and that results in the release of acetylcholine into the synaptic cleft. Once acetylcholine has been released into the synaptic cleft, it attaches to the nicotinic receptors. Once nicotinic receptors has been stimulated, they undergo a conformational change, and that results in sodium cations moving into the muscle, an influx of sodium cations. Once there is that, the muscle depolarizes and contracts. So these are the steps that happened. The reason why we are doing this way, I'm giving you a summary like that, is because whatever that happens that makes any of these steps not to occur or not to take place will result in a muscle not contracting. We are going to talk about myasthenia gravis. We are going to talk about Lambert-Eaton syndrome. We're going just to understand the neuromuscular junction disorders, even the drugs that affect the neuromuscular junction. So when I come back, I did this video just because I'm on lunch now. So when I come back after work, we're gonna finish off. So for now, this is the physiology that I wanted us to understand and grasp. So when I come back, we're gonna talk about the disorders that affect the neuromuscular junction. Doesn't make sense that we only know about muscle relaxants which affect the neuromuscular junction and not know other pathologies of the neuromuscular junction, because we are here now, so we might as well put everything into its place. So thanks for watching, guys. Thank you.